Welcome to Industrial PLC Application. This video is on PLC Network Communications, Part 1, Hardware. After completing this video, you should be able to identify basic Ethernet components and hardware, explain their different functions, identify and explain their MAC ID, and identify Ethernet addressing. PLC communications have come a long way. When we worked with RS Links, we saw a large number of legacy communication drivers that allowed older PLCs, I/O, and programming terminals to communicate with each other so that troubleshooting and programming could be achieved. Today's networks and network capabilities allowed a wide range of equipment to share data and execute logic. Since many devices have adopted Ethernet hardware, they share a common platform. In this video, we will focus on some of the primary equipment needed to set up a small network and then identify the different devices on that network. Up to this point, you've been using the USB port to communicate with the MicroLogix. There's also a serial port for RS-232 and legacy communications. We're going to be focusing on the top one, which is Ethernet. To begin with, let's remember first and foremost, Ethernet, no matter what the hardware looks like or its speed, is first and foremost about sending data. This means that the package of the data must be the same so that any receiving device can unpackage the data and put it to work. And secondly, or perhaps of even greater importance, is that the data must be sent to the correct recipient. On the packet overlay picture, notice that the third section from the left says Destination MAC address. This is like putting the address on a letter. So what is a MAC ID? Well, MAC ID stands for Media Access Control Identification. It's a unique 48-bit number that is burned into every Ethernet device's firmware and is expressed in hexadecimal, or base 16 numbers. This Micro 850's unique MAC ID is 5C6816A3-2A35. This is how Ethernet resolves your phone from this PLC, even if you were on the same network or even hub. So now that we know we have a final address, why do we use IP addresses? Well, we're going to look into that shortly. But first, let's look at connecting the dots with other devices. You may notice that we have not mentioned Wi-Fi. Besides the additional expense, anyone who has worked inside an industrial building knows there are areas with no Wi-Fi service, no cell service, dead zones. That could be catastrophic in automation. So although some may be making inroads, it's not likely to be fully utilized in automation for some time yet. That said, our first connection must be the Ethernet cable itself. Most Ethernet local area networks, or LANs, still rely on a family of wired computer networking technologies. Although IP67 and IP69M12 connectors are used for field devices, the hardware port on the Micro 850 accepts the standard RJ45 connector cables. With these cables, both ends of the cable have male connectors, but it is how they are pinned that determines how they're hooked up. With Ethernet connections, the final termination determines whether they work or not. There are currently 3 wiring configurations in use today. The 2 layouts that are shown are the latest proper connections you should be using. It's the final connection application which determines which one of the 2 you use. See if this helps you remember. Switches and routers use straight through. PC to PC crossover, please. It's likely you've seen one of these at home. Everybody knows it's a router. But what does a router do? A router is used to connect one network to another, and then direct Ethernet traffic to devices connected to it. One side of the router talks to the Internet or ISPs, large internal networks, data concentrators, and other large PCs. The other side talks to smaller devices or end users. You may not be aware of this, but the router at your home actually has two parts. It has the switch side and the router side. The switch side connects devices to the router. The router, or WAN side, connects the devices to the wide area network, or the Internet. It has its own IP address and a MAC ID, and it creates its own subnet and creates the subnet IP addresses managed by the switch. Once you leave the home, routers and the switches tend to be separated. That's because they perform two distinct functions. Routers control traffic on the client side by assigning internal IP addresses. They have their own internal IP address as well, for example 192.168.0.1. This allows network administrators to manage the throughput. There is also thousands of internal ports that channel specific Ethernet traffic and acts to prevent unwanted traffic for security. Routers can also analyze a given data packet's destination IP address and can calculate the best way for the data to reach the final IP address and will pass it through. Switches, on the other hand, are used to add devices to a network, to expand it internally. They come in two distinct types, managed and unmanaged. Managed switches can also be used to create VLANs, or internal virtual local area networks. VLANs are not accessible to external networks or to other portions of the switch. The switch can also direct traffic from switchport to switchport, but not beyond the router. High-end switches can create internal IP MAC ID tables to speed throughput. They cannot talk, however, to other networks and must use a router to do so. In Lab 3, we did some rudimentary exploring of IP addresses, and then earlier in this video, we mentioned them in the discussion of routers and switches. What exactly is an IP address? Well, to begin, the IP stands for Internet Protocol. As mentioned, there are four types of IP addresses, but we are only concerned with two, dynamic and static. Dynamic IP addresses are ones that are temporarily assigned by a router or other network managing device that controls DHCP. DHCP stands for Dynamic Host Configuration Protocol, which basically means the host, that is to say a router, will assign the IP addresses as required to manage the network. Every time a device connects with a network, it will be issued a new IP. This is part of the reason that the IP address, even for the simulator, seems to constantly change, and why connections that once worked no longer do so, even though you're connecting to them through the same network. The other reason is the Micro 850 itself. The Micro 850 has its own DHCP procedure. It pings the network and listens for a response from a DHCP controlling device. If it doesn't receive a response, or it isn't assigned an IP, it will do so on its own. Notice it will poll other devices to detect a potential IP collision, that is, two devices with the same IP. Static IPs are ones that do not change over time. These IP addresses are assigned by either an ISP, that is an Internet Service Provider, or a network administrator. When dealing with automation, IT administrators want to keep the traffic of production away from the traffic of administration, etc., or the Internet. Static IP addresses help to assure this if the company has an IP policy and enforces it. While on the subject of network administrators, keep in mind network security. Most Ethernet networks are set up with a high degree of security. This prevents unauthorized access to changing those parameters. Many of the procedures discussed here require access to the network not normally available to typical users. Before working on a network PLC, contact the network's administrator to discuss what work will be done. We've covered a lot of ground in a short time. We've identified some basic Ethernet components such as cabling, switches, and routers. We've reviewed MAC IDs and IP addresses, both static and dynamic. In our next video, we will connect the components into a working network and look at VPNs and VLANs.